everyone, how's it going? And welcome to the Community Conversations. My name is Liz and I am from the Dfinity Foundation. So today we have a very special treat. We have OpenChat founding developer Hamish Peebles here to walk us through how to build a Dapp in the Rust programming language on the internet computer. And Hamish is very proficient in the Rust programming language, so feel free to take it away.
So I've been doing Rust for about 6 months or so since starting OpenChat, essentially. Can you see my screen?
Yes, I can see it.
Okay. So you can kind of ignore what's on the screen for now. For this talk, I thought I would essentially just walk through a fairly simple service built in Rust. So rather than go through the OpenChat code, which I was tempted to do, but I think it's just a bit of a big, it would just make the talk a bit complex. So I think this smaller example, this was the plan I went with. So what this is called ICP notifications, and it's open source and up on GitHub. I'll send a link round. In fact, I'll send a link round now, in case people want to see the code while we're talking through it. So there's the link. I think you can see that. So what this service does is, well, this service does nothing yet because it's not finished. I just knocked this up in a few days and it doesn't have a UI yet. And it's still waiting for some functionality in the ledger. But what it theoretically would do when it's finished is users who want to be notified of when they receive ICP can come along to this service, put in their account identifier and put in either a phone number or an email address and click subscribe. And then what that will do is, in the background, this service is using the canister heartbeat functionality to sync in transactions from the ledger. And then if it sees transactions for any of the accounts that are subscribed to, it will push a notification by text or email to that account. So for building a canister in Rust, so I've kind of used the same layout we've used in OpenChat, which may be slightly overkill for some more simple services. But in OpenChat, we have lots of canisters. So what we have is a canisters directory, and then there's also often a lot of shared functionality that we use between the canisters. So we put those in a libraries directory. So let's start by looking in canisters. There's only one in this example app, and again, kind of using the model we've used in OpenChat, we have an API directory which has its own package, and an implementation directory again has a separate package. By doing it like this, if your service grows into multiple canisters, when you call between canisters, you can just reference the other canister API packages. You don't need to reference the whole implementation. And so it means it keeps your WASM sizes smaller. So the first thing to do is probably to define your candid file. Oh, also, I'm assuming a basic level of Rust here. I'm not going to go into the Rust language itself, as in, basic features of Rust. I'm more going to focus on how you can build the canisters, given that you know Rust. So the place to start is probably a candid file. So you would define the methods that your service is going to expose. Obviously, you don't need to know all of these ahead of time, but as you build your service, you start with them one by one. So in this service, we want to be able to subscribe. We want to be able to unsubscribe. We want to be able to get your list of subscriptions. And then these two, so I've kind of cheated here. This is actually going to also be running an external service for polling the subscriptions, because currently you can't do push from a canister. So the way that we're going to push these notifications out to users is by running some executable in like AWS or Azure or anywhere, but it's not on the IC, not for now anyway. So that's what these two methods are for. They're for getting the notifications and then for removing them. And so, you just need to specify all your arguments and your response types and everything. So a pattern that we've kind of settled on in OpenChat, which I think works quite well actually, is to split each of your publicly exposed methods into its own file. And so you can have all of your queries and you can have all of your updates. So if we just look at one of these, so for example, subscription. So this is for getting a subscription. Actually, let's not do that one. Maybe subscribe. So when you subscribe, you would pass in your vec of account identifiers that you want to subscribe to, and then a vec of, I've called these notification targets. And so this would be things like, well, there you go, email or phone, email or SMS. And similarly, all of these just follow the same pattern. They have called args and then response. One nice thing about keeping it consistent with args and response, which you aren't actually able to see here, but we've done it in OpenChat, is you can use macros to generate all of the inter-canister queries because they all follow exactly the same naming convention. I haven't got an example here though. OpenChat will be open source soon, and then you'll be able to see it. So let's just dig into some of the implementation. So it's probably worth, if you haven't watched it already, Roman did a talk last week on building canisters with Rust, or just building in Rust, I think. And with Rust, it's quite hard to have global variables in any nice way. But essentially, the way that he and a few others have settled on, and they're the Rust experts, not me, not yet, is essentially using this thread local pattern. And so by using this pattern, every time you access it, every time you want to pull data out of your global state, let's just go to an example. For example, subscribe. Let's ignore that. In subscribe, it accesses that global state like this. So you have to pass in a closure. And although it's thread local, what that means is that on the first time that you access this state, it will be initialized with a default value. So you need to pass in here, you need to pass in something that has a default value. If your state doesn't have a default value, what you can do is you can wrap it in an option, because then obviously it will default to none. And then you can initialize it during the canister initialization. So if we go back to subscribe, you'll see that what we do is we borrow what's inside that global state mutably, and then you can pass it to another function which handles all of your logic. So again, this is a pattern that we've really used heavily in OpenChat, where we access the global state in as small a function as possible, and then just pass that on to another function that handles all of your actual logic. And what's really nice about doing it this way is that it's really easy to test. Because if in this example, everything that's related to a canister is encapsulated in these 4 lines, and then the function where all of the kind of logic, all the meat of it takes place, is just easily testable. It's just a pure function. And so, for example, here's some tests on it. So, okay, so for setting up a canister, let's start with, if we look more in the lib. So using this pattern, this runtime state, essentially your state is made up of your data, and then the environment is essentially a set of functions that can extract things from your canister, such as the time, the caller ID, the canister's ID. So let's go into this. Okay, so for here, it's only using now and caller, but there can be other things in here. For example, if you want to be able to generate a random number, you can put it in here. And you'll see that it's a trait. By having it as a trait, again, it just makes it easy to test. So if we go back to the test, if we go back to this function, it takes the runtime state. And so obviously when you're running it in a canister, you implement it, the environment trait with the canister implementation, which will use the Rust CDK to get things like the time and the caller. But when you want to do it in a test, I think I've got that somewhere here. Yeah, so in this env module, we define the trait, and then there's one implementation for when you're in a canister, this canister environment, and then there's one for when you're in a test. There is actually this empty environment as well, but this is solely used for when you're initializing the state so that there can be a default value. So if I go back to the lib, this needs to have a default value in order to be able to use it as the generic type in the thread local ref cell. So we want to just be able to specify an empty environment, which will then get overridden during the initialization. So I guess that's probably the next place to look. And you'll see I've organized this implementation package into queries and updates. The model is kind of encapsulating all of your business logic, all of your, all the business logic. Then lifecycle contains things like your initialization, your heartbeat, the pre and post upgrades, which we'll come to shortly. So let's look at initialization first. So yeah, this is always worth calling at the very beginning of your initialization, because what this does is it will wire it up. It will wire it up so that anytime there's a panic, it will write out. In fact, we can see it here. Yeah, it will write out the text from that panic so that you can see it. So that's just something that's worth doing for helping your debugging. If you just call that when you first do the initialization, then yeah, you see here I've created a canister environment, then the default data and ledger, will come onto that. And then I set my runtime state, and I set the global state to be the state that I've just initialized. Bit of a sore throat at the moment. It's not coronavirus, don't worry. So yeah, so that's the initialization. So then if we follow on from the subscribe where we were looking before, you'll see it calls into the runtime state data subscriptions add, and this comes from in model. As I was saying, you encapsulate your actual logic in here. And so if we look at the subscriptions, in here, you can get your subscriptions. You can get all of them, or you can get a single subscription. You can get by account, as in by the account identifier, or you can add a subscription. Is it worth looking into this? Again, I think I put test down at the bottom. Yeah, so it's quite testable. There's nothing that's canister specific here. It's all just like vanilla Rust code, which you want to do as much as possible. If you can keep all of your canister specific code off to the side, then it makes it very easy to write tests just using normal Rust. If you had lots of stuff throughout here that was doing canister specific logic, like if you were using the Rust CDK to make a call to another canister or getting a time or whatever, it would just mean that you can't test this with unit tests anyway. And at the moment, integration tests are pretty much impossible. They're not, but they're not it's not very nice to use integration tests at the moment. I think that's being worked on. There's the link to the repo. Yeah, if anyone does have any questions at any point, feel free to. I literally just glanced at the chat as he posted that message. So, okay, so let's look at the heartbeat. Heartbeat is you can define a heartbeat function, and what that means is that this function will get executed on every block height. So if you want to run things in the background, any background processes, essentially, you can use heartbeat for that. So in our case, what we want to do is we want to pull in all of the transactions from the ledger. So again, using this model with acquiring a lock on the global variable, this runtime state. But you'll see this time we do it 3 times. Well, actually, it only happens twice, but because there's an if arm, so there's an if, so it only ever goes into one of the arms. But the reason we have to do it twice is because this is an asynchronous function, and when you're doing things asynchronously, it gets a little bit harder than the model we had here. This was very simple because it's synchronous. You can just acquire your lock, do your processing, and you just return. Nice and easy. But in this case, what we need to do is we need to look at the data. We need to extract some data anyway to kind of work out what we need to then do in this asynchronous path. So let's look in prepare. So because this heartbeat runs on every block height, we need to ensure that there's not 2 ongoing at the same time. So within this prepare, it does this try start import. And inside here, again, this comes from the model directory where all the logic sits. It will say if it's in progress, return false, otherwise set it to in progress and then return true. So this transaction import state, we just need to have, are we in progress, true or false, and where have we currently synced up to? So if we go back to the heartbeat, we say, if we were successful in trying to start the import, that means it's not already running, then we clone an instance of this ledger. And so let's look at that ledger now. This is essentially the client for calling into the ledger canister. So it will call canister to retrieve either the tip of chain or get block since. So this isn't implemented yet, and this doesn't actually exist, but I've been told that it is coming. So I've just put this here as kind of a placeholder, and once it's available, I'll be able to fill this in. But if in the other code, we'll just assume that it's there. So, and also you see here that it's an arc. What this is it just means that we can use it between threads. So whenever we want to call into the ledger, what we can do is we can just clone this arc, and that will give us a new reference to the existing ledger client. And you'll see that here. So in the result, we return the cloned ledger, and we return what transaction index we have currently synced up to. And in the other case, we just return saying we're already in progress. So back in here, we say if it matches with ready and we get the ledger and the index synced up to, then if synced up to has some value, as in if it is some rather than none, then we can go and get the next transactions. Otherwise, if synced up to is none, this will only ever happen on the first time. And in that case, we need to just call tip of chain, and that will tell us where the ledger is currently processed up to. Because obviously, when the service first initializes, we won't have synced any of the ledger transactions, but we don't need to sync any of the transactions that occurred before we first call this. Because obviously, we would have no subscriptions until the service starts up. So this happens on the very first case. Every other case, we come in here and we process the transactions. And so the asynchronous bit happens while we don't acquire a lock on the global state. And that always has to be the case. And in fact, the Rust compiler will ensure that. So you can't pass an async function into here. So there's no way of holding a lock onto this global state over an async process, which is good. You want the compiler to give you all of these guarantees so you know that you're not shooting yourself in the foot. So process transactions. This just iterates through the transactions we had, and it looks for any subscriptions based on the account identifiers. And if there are any, then it will add them to the list of notifications to push out. And then we mark the import as finished. So I think if people want to dig further into this, they can look through the code. I think because there's not that much time, I'll just gloss over bits like this, which is just kind of vanilla Rust. So other bits that are deving on the Internet Computer specific, I think it's worth looking at how to do upgrades. So this global state, when you upgrade your code, we need to ensure that the state, in fact, not all the state, just the data, we need to ensure that the data persists between one version of your code and the next version. And so the way you do that is by using pre and post upgrade. So if we look at pre-upgrade, so when you upgrade the code, the pre-upgrade will run on the previous version of the code, and then the post-upgrade version, the post-upgrade will run on the new version. And if either one of them fails, like if a panic is thrown in either one of them, then it will roll back the state and it will roll back the upgrade, and the previous version of the WASM will continue running. So one thing to be aware of is that you want your pre-upgrade essentially to never fail. Because if your pre-upgrade fails, then you have no way of upgrading to a newer version. Whereas your post-upgrade, you want to fail if anything at all goes wrong, because you can fix the post-upgrade and try it again, whereas you can't fix the pre-upgrade and try again. So you really need to make sure your pre-upgrade doesn't fail. So let's look at this pre-upgrade. Noticed unsafe blocks in a few places. Did you? Not in the code I've written. There is unsafe blocks in the Rust CDK, if that's what you're talking about. I don't think there's any unsafe blocks in the code I've written here. So, okay, in this pre-upgrade, again, it acquires a lock on the, well, I guess it's not a lock, but it acquires the global state. And then what it does is it serializes it using candid. And also you'll see here, I've put a version in. So in our case, we want to say stable memory version v1. By doing it with a version, it just means that if you're in a single canister, oh, okay. I didn't realize that. Which macro was that? Where's that? That was in it. Yeah, so within the CDK. So the Rust CDK does have a few bits of code which are unsafe. And actually, this is essentially one of the old ways of doing global state in Rust. So you see here, they've got static mute, and you can only access that using unsafe. Whereas if you watch Roman's talk on Rust, he went through a few of the different ways of doing global state, and essentially this way was mentioned, but it's not a very nice way because you lose all of the compiler guarantees using this. Whereas if instead you use thread local and then have a ref cell, everything, you still have all of the compiler guarantees. So you don't need to worry, there's no unsafe code, and you don't need, so I haven't written any unsafe code myself in this repo. And so, yes, we are depending on the Rust CDK, which does have some unsafe code, but to be honest, that should probably be brought up to date with this latest way of doing global state, and then we can remove the unsafe code. But back on the pre-upgrade. So yeah, it's good practice to pass in a version. If you're running just a single canister service, maybe it's not as important because you'll always just be incrementing the version by one. But in OpenChat, every user will have their own canister, and sometimes we may jump versions, like a user might go from version 1 to version 6 or whatever. And so we need to be sure that in our post upgrade that we always deserialize with the knowledge of what version the state was serialized against. So let's just look back at the pre-upgrade again. So what it does here is it serializes the version number and it serializes the state. And this is the data type that came from that global runtime state variable up here. And then we just encode the tuple with the version and then the data. And then in the post upgrade, we can retrieve those bytes from, you can do from the Rust CDK, you can do the stable restore. And you have to do this fairly weird syntax because Candid is, Candid works on tuples. And so this is actually how you would define a single value tuple. So in the pre-upgrade, you'll see I had to do the same. So this is a vec of U8, but then we pass into stable save a tuple with a single value whose type is a vec of U8. That's why it's got this weird like comma and then empty. So in the post upgrade, we do the same. And then what we need to do is same as in the initialization, we need to set up the environment. We need to build that ledger client. And then we need to deserialize the state. So in deserialized state, the first bit we do is deconstruct it into the version and the state. And by doing that, you can just tell Candid to decode it into a vec of U8 and a vec of U8. And so by doing it like this, we can easily extract the version before we start deserializing the state. So then we can deserialize the version, and then you can do a match on the version. And obviously in this case, there is only V1. But if there was stable memory version V1 and V2 and V3, whatever, each of them you would have to deserialize, and you'd have to handle each one separately. So obviously this is a really simple example, but you'll kind of see what I mean in terms of if you had it more complex, it would still be relatively straightforward to handle it because each one would just be handled by a different arm in this match. Okay, so that's upgrading. Oh yeah, and you can put tests on it. So you can test deserializing from V1, you can test from V2. This isn't a very good test, really, because I just added a tiny bit of data and then serialized it and deserialized it. I haven't actually done this myself, but I think it would be really nice if for writing these tests, you could populate loads of data into a running canister and then extract the state. And then you could just drop that big state object into your test, because that would be a much better test than just this kind of gimmick where I've just put in a single value and then serialized and deserialized. It'd be much better to try and deserialize an actual running state, but I'm not entirely sure how you do that. So another thing that's that you can take advantage of when building canisters is there's a thing called inspect message. So whenever you're running services, you have to pay for all of the processing. You're paying for the cycles. And so inspect message allows you to exclude certain requests before they go through consensus. So when a message comes in, when an ingress message comes in, as in a message from the outside world into the internet computer, if your canister, if the canister that message is going to be delivered to implements inspect message, then the canister that receives that message will execute inspect message. And if it doesn't call accept message, then that message will be dropped and it won't be gossiped to the other replicas. And what's good about that is that you can save masses of cost, because say someone's trying to hammer your canister with invalid requests or whatever, you can just exclude them all earlier and leave your canister to run on the valid requests. And so it's not going to use up resources. It's not going to use up the processing power. But when you run it, you don't have all that many things available. Like you can't look at the args. I don't think you can look at the args anyway. I think you can essentially just look at the caller and the method name, but that might be wrong. So in this case, I only want remove notifications. I only want remove notifications to be called from the push service that I will have running. At the moment, I've got it running in AWS, and I know the principal that it runs under. And so I can put, when I'm initializing my service, I can set that principal. And then, so what I've said is, if the method name equals remove notifications, only accept if the caller is the push service. And actually, I realize this doesn't work because you need to call accept, otherwise the message won't be accepted. So every other method is open to anyone. So I should have added this. So yeah, how do you decide what's a valid message? So I think, although this may not be true, I think you can only exclude currently based on the caller. So in open chat, in fact, we can open that. So in open chat, in the user canisters, we use inspect message where we only accept the request if it came from the owner. So, well, actually, anyone can call deposit cycles, but then all of the other methods, we only accept ingress messages from the owner of the canister. I don't think you can look at things like the arguments. Maybe you can. If you can, I'm not aware of that. So, okay, so that covers, we've looked at heartbeat, pre and post upgrade, inspect, initialization. Are there any questions? Now could maybe be a good time to take some.
We do have questions. Is this like the end of the walkthrough, or?
I mean, I think I've covered all of the canister specific stuff. I mean, there's more code that we can go through, but it's just vanilla Rust, really. So it's probably not that worthwhile to look at.
Okay, definitely. So I can, let me pull up the list of questions. Oops.
Oh, Demetrius has just said you can look at the args. So that's good.
Thanks, Demetrius. Okay. All right. Thank you, Hamish. So, first question. You mentioned that the Rust CDK has code that's unsafe. Will this be updated?
Um, we can put a, we can ask the SDK team. It's not really something that I'd be able to do, but I guess if someone raises an issue with the SDK team, or in fact, I think is the SDK open source? I think the SDK might be open source, and so that could be a nice job for someone who wants to get involved to just remove all the unsafeness from the SDK. That'd be good.
Yeah, no, definitely. That's already been open source, the Rust CDK.
Okay, yeah. Oh no, of course it has. Yeah, the CDK. Yeah, of course it has. Yeah.
Yeah, so open to the community to update. So next question, Hamish. Hello, Hamish. Thanks for the presentation. I am new to building on the internet computer. Would you recommend building an application in Matoko versus Rust? And are there things that are possible in one language but not the other?
Oh, so I've never actually built in Matoko, so I can't really vouch for that, although I have heard good things. I think if you know Rust, then go with Rust. But if you're just looking to build something that's fairly simple, you'll probably get it done a lot quicker in Matoko, because Matoko is a much simpler language, and also it's just easier to build on the internet computer with Matoko, because Matoko is built specifically for the internet computer. So you don't have to jump through a lot of the hoops that you do with Rust. Like, for example, this global state stuff, you don't have to do any of this kind of complexity with Matoko. You can just define something as, I think you define it as stable, and then you can just have it easily persist between upgrades, and you can access it easily without having to do the thread local stuff. I haven't done Matoko myself, but I think you'll be much quicker to build with Matoko. But when we were building OpenChat, we thought we'd go with Rust purely because we started it about 9 months ago or so. And I think we just thought it was less risk to go with Rust, which has more libraries we could just pull off the shelf. And yeah, it's just more mature language. It's, there's more content. If there are issues, you can look them up more easily.
I see a comment from a community member in the chat saying, I know JavaScript. I ended up trying both and decided on Matoko because of examples available. Rust developer experience is far more enjoyable.
Oh, right.
Interesting.
I mean,
yeah.
I like the Rust language. So there's that as well. If you try both, and realistically, yeah, just if you prefer one, then go for it. But I don't think there's things you can do with one that you can't do on the other.
I know that Paul Liu from Dfinity is also on this call, and I believe Paul has experience with applications in both Matoko and Rust. So, Paul, if you have any thoughts, you can also chime in the chat. So, I also saw a comment in the chat saying, "How are you getting access to the principal data in the inspect message function?"
Yeah, I saw that. So, you'll see, anytime that we want to query the environment or our global state, we need to use this pattern. We use this thread local runtime state, and then you pass in a closure, and within that closure, which is this one, we can access the env property, the env field, and this env field just has a few methods on it which we can use to get things like the time and the caller or the canister ID. And if I'll show you the implementation, it's this trait, but when you run it in a canister, we use this implementation, and it's just calling into the Rust CDK. And so you can call caller and it just returns IC CDK caller. And in the test one, it just calls self caller. Oh, so you would need to initialize the test one with the caller and also the time. By doing it like this, you can, in a test, you could make a call from one caller and then create a new test environment from another caller to see how it looks with two different callers or at two different times. So you could bump the time by an hour, and then that might cause something to happen. And so it'd be easy to test it because you can just pass in any values you want here. Yeah.
Thanks, Hamish. And I saw that Paul has chimed in the chat saying, yeah, there are things you can do in Rust that are not available in Matoko yet. For example, inspect message.
Right. In fact, inspect message, I added to the CDK about a week ago, purely so that I could show it in this demo. So I guess they haven't done it in Matoko yet.
Cool. Thanks, Hamish. Next question then. Are we making any efforts to reach out to the core Rust community to promote building on the internet computer?
I don't know. That would, I guess, Liz, you might know. You're more of the community person.
Turning the tables around, I see.
Yeah.
No, that's totally fair. A little bit of a Uno reverse card. Yeah, we definitely have a lot of plans in the works in terms of developer conferences and sponsoring conferences and so on and so forth. I don't want to announce anything prematurely before it's ready, but that's certainly something that has been top of mind for us, of course. Although I saw a very interesting stat yesterday. I think it was something like 75% of developers building on the internet computer are using Matoko, and 25% of developers are using Rust, which is interesting because Rust is an existing language with an existing community. So what that tells me is that we definitely have a lot of room for growth in terms of the Rust community. So thanks to the efforts of people like Hamish, hopefully we can make it as easy as possible for people to be able to build in Rust if they already know Rust. Sorry, go ahead.
Oh, I was just reading back through the chat. I saw there was a question earlier about open chat. How do you decide the hierarchy between user profiles, rooms, and messages? How do you decide between a single versus multi-canister architecture? So we kind of went to the extreme in open chat where every user has their own canister, every group chat is in its own canister, which it simplified the code quite a bit. But it does mean you end up with tons of canisters, which does have its drawbacks. Like, for example, we need to keep them all topped up. We need to create them to begin with. Every time you create a canister is 0.1 T cycles, which is essentially like 10 cents-ish. And so, you need to account for that. Whereas if you have everything running in a single canister, that's probably quite simple too. I think in terms of code, it's either simplest to be all in one or split everything. What would be hard would be to have maybe 100 users per canister or something like that. Yeah, so Cycat, that method you can't access from Matoko. I hope I didn't just butcher your name's pronunciation. So it's only recently been added to the Rust CDK, and I guess they just haven't done it in Matoko yet.
All right, so we just got another question. So what is the difference between the runtime state and something like the IC SDK storage to store data and state?
Right, so this runtime state is something that we've defined. This is just a normal Rust variable. Whereas, so this is still just vanilla Rust code. Whereas if you look in the pre-upgrade and post-upgrade, where is it? So to get the bytes that we want to save into stable memory, we use this runtime state variable, and we pass the data into this serialized state function, and then we encode it as candid. And then once it's in bytes, we use the CDK to save that to stable memory. So this global runtime state variable is essentially what we use to handle all of our requests and for querying our canister environment and things like that. But then between upgrades, this will die. So what we need to do is we need to serialize this, or at least serialize the bits that we want to persist between upgrades, and then use stable save to save those bytes. And then in post upgrade, we read the bytes out again with stable restore. And then once we've done the restore, we can deserialize those bytes and reassign the global runtime state.
Cool. So there is a follow-up question to that. So should we really only use the storage from the CDK for pre and post upgrade? Because in the profile Rust example from the docs, it uses the storage stuff to save profile information.
In the profile Rust example from the docs, are you talking about in the CDK? Docs, no. Examples, profile, So because in the profile Rust example from docs, it uses the storage stuff to save profile information. I think I know what you mean. Are you talking about this? It uses storage get. So yeah, this is essentially the equivalent of the global state here. I think you should watch the talk that Roman did last week, where he explains that actually it's quite dangerous, or it can be quite dangerous to use this method from the CDK. And I think he was putting forward a case for it should be deprecated, really, because internally here, storage get, in fact, I'll be able to look at the implementation in storage get and get mute. They're both, yeah, here we go. There's get. Oh, it just calls into get mute. And in here, if I thought this had some unsafe code. Yeah, so this uses unsafe, and you essentially lose all of the guarantees that Rust would normally provide you with out the box. So what it means is, if you see here in an asynchronous method, I was taking a reference on the global state and then doing an asynchronous thing, and then taking another reference on the global state. And the Rust compiler won't let me hold a reference to the global state over this async action. Whereas if you were using that method from the Rust CDK, the compiler would just say, yep, that's all fine. But that could cause big issues where you might take a reference to something, then do something asynchronous, which could completely mutate your state. And then your state variable here, if you were using the Rust CDK version, you could access it again, but it's all completely changed without your code being aware. When it's available, watch Roman's talk and he'll describe it in a way better way and with actual examples rather than that kind of waffle that I just gave.
Cool. Yeah, that talk will be posted very soon. And when this talk is published, I'll also include a link to that, as well as the GitHub for the project.
If you want to build canisters in Rust, definitely listen to that talk. Like, it's really useful. I learned a lot from that talk, and a lot of this stuff is based on that talk.
Cool. Thanks, Hamish. So next question is a little bit spicy. So the application, the project you walked us through uses AWS, but I thought the idea behind the Internet Computer is that we don't have to depend on centralized tech infrastructure such as AWS.
Yes, that is a very good point. So I didn't actually show that bit. But essentially, yeah, there is a service which will be polling into that method to get the notifications and then remove notifications that it's pushed. And yeah, annoyingly, we can't do that yet purely on the Internet Computer. It will be possible someday, but you can't make outgoing HTTP requests from the IC currently. I think that's being worked on. I don't know, I'm not close with the core team there. But I think I have heard rumors that is being worked on. And once it is, then we can swap from having to poll to using a push model. But I think that shouldn't prevent us from building things that will be useful if we do have to run a little bit outside the Internet Computer. Like, for example, I think this service will be pretty useful for people who have ICP accounts, and they would just get a text every time someone sends them ICP. That's quite cool.
Awesome. I see some.
Exactly. Utility greater than purity. That's nice.
Yeah, and I see there's another comment. IC530, I believe, is the internal feature for outgoing HTTP requests. Seems
Okay,
like
cool.
it's definitely being worked on.
Okay.
So thanks for that as well. And there's also a forum thread talking about HTTP requests from canisters. Excellent. So I can make sure that's reposted as well in this video. So we're coming to the end of our questions. So if you do have additional questions for Hamish, definitely feel free to drop it in the chat. So Hamish, we have an open chat question for you. Is open chat open source? And if not, when will it be open sourced?
No, and soon. So the version that's live right now was kind of just a very early demo that two of us built, myself and a guy called Matt Grogan. And then we had a third guy join the team who's a really good front-end specialist. And so when he joined, we already had plans to re-architect the whole thing to be really scalable and canister per user, canister per group and everything. And when he joined, that was our kind of trigger point to stop what we'd done on V1 and start again in V2. And we've been doing that for about 2.5 months now. And our internal goal is to get it for early November to have V2 live. And once that goes live, we'll open source it. So a month and a bit. Watch this space.
Stay tuned for more.
Yeah.
Okay, so that was the last question that I had. So unless anyone has any final questions which come through, that will conclude our community conversation on building a Dapp in Rust. So big thanks to Hamish for walking us through, and also shout out to the community for tuning in from all over the world, and for all of your excellent and technical questions. So thank you again, Hamish, and see you guys all at a future community conversation. Bye, everyone.